So these are the 3 steps to create that beep VI that we just made, and I'm going to leave this for a second and take a look at that code again, because there are a couple of items that came up that are good to know about. First, this question mark tunnel is a terminal, so it's not the same as doing this. If you just collect this to the sidewall anywhere, if you connect this anywhere on that border, it's not the same. What this does is it brings in data into the interior space in all circumstances. So that's called a tunnel. The tunnel brings in data to both cases, both frames of the case structure. If I hit Control Z a couple times, we've undone that. Now, one problem with this code, if I run it again, is, or actually when I ran it the first time, is you could hear beeping long after I hit the stop button. And the reason was that this loop is executing incredibly fast. In fact, if I right-click on the iteration counter and I create an indicator on it, that's a nice little trick, by the way, that I'm not going to go into detail of, but whenever you right-click on a terminal, you can create an indicator. We'll talk about that more when we get into the LabVIEW coding part of this with respect to the robot. So I created an indicator. This now tells me how many times the loop's iterated. Watch this. So this is my loop iteration counter. I put it down over here and I hit the run button. So how many times did that loop happen? 15,000 times. That's a lot of happening. And in fact, it had asked the computer to beep more times than the computer could beep. It couldn't beep that fast. So it's actually still beeping in my ear right now. So it put 15,000 beep requests in. Well, maybe we don't want this thing to run as quickly as possible. So one way, and I'm not going to turn this into an exercise, but just so you know, one of the ways to slow a loop down is to put a wait statement into it. So there's a function called wait. This function will make the program go to sleep for a certain amount of time. If I hit Control H, you can see it's called wait ms. What do you think ms means? Milliseconds, right? So to make this meaningful, I might want to only beep every quarter. In fact, it's still beeping in my headset, by the way. It's 15,000 beeps that have got to come out. I say OK. I close this. And what I can do here is right-click on this and create a constant. You can create an indicator. You can create a constant by right-clicking on a terminal. And let's say I want to make a beep request every quarter second. Okay? So now when I run the program, every quarter second I get a beep. It's still doing the 15,000 beeps, by the way, as fast as it can. But it'll get through those eventually. The big beeps that happened, I could hear that they came out more slowly. And notice you could see that this only iterated 15 times. So if you want to slow a loop down, which is usually not what you want to do on these robots, you put a wait statement in. Okay? We'll talk more about that in a bit. What's that? In the space, right? Because essentially the loop can't split into different parts, right? So if all this stuff happens really fast, but this stuff happens slowly, then the loop can't half iterate. It can't iterate half of itself. It's not like ladder logic where each ladder executes on its own. No, this is, everything is in one loop. It's lassoed together. So the slowest thing defines how quickly the loop can reiterate. Does that make sense? Okay. I don't want you all to get into beep trouble, so we're going to take this beep out to do the next thing. So we don't want to beep anymore. What I want to do is I want to give better instruction to the user. All right? I don't want to just say it was too high and okay, because essentially we know that those goals, they have a top edge to them and they've got a bottom edge to them. So I want to make a program that gives 3 instructions now to the user. If it's too high, I want to say don't shoot, move down. If If the number's above 7. If the number is below 4, I want to say don't shoot, move up, because it's too low. And if the number is in between 4 and 7, I want to say shoot the ball. So how are we going to implement that? How many cases does a case structure have when you drop it initially? It's got a true case and a false case. Are there any other ones? By the way, it just stopped beeping, finally. Good. There's only 2. So how do I get a third one in there? I could try to right-click, make a new frame. There is no make a new frame, so that's no good. What else? But it's a good thought. So what if I did this? What if, in the true case, I put my don't shoot, and then let's say move down, right? Because if this is true, that means I was greater than 7, right? So that means I'm too high, so I definitely don't want to shoot in the true case. Control B, by the way, removes broken wires. You don't have to memorize that, but it is right here. Remove broken wires is B. Now, in the false case, well, and actually, what I want to do is put that instruction out to the instructions output. And this is where I'm going to have to switch from tile mode to full screen mode, because I just don't have any room left. Usually you want to program in full screen mode anyway. So I'm going to make a little bit more room here, and I'm going to put my instructions on the outside of this. So if I want don't shoot, move down to go into instructions, I go through the edge wall of the case structure, and this has made a tunnel. That is an output tunnel to the case structure. Did everybody see that? Because I see some people are working on this, and my suggestion is you don't work on it. You just watch what I'm doing and listen, and then try to recreate it, because then you'll hear everything. So I've got an output tunnel. In the false case, do I know whether I'm below 4? I just know that I'm not above 7, right? So I've got to put another condition or another comparison in that is my less comparison. Now if my height is less than, create, right-click, notice I right-clicked on the output terminal. You could also just grab a numeric constant, by the way, but I'm just doing a little faster. This trick is you right-click on the terminal, so you get right over that terminal and you can create a constant. I want to know if I'm below 4. Is height less than 4? Now, could I have this switched around? Would it work the same? No, because then it would be if 4 is less than the height, which is a totally different statement, right? Now, what can I do with this? Inside of my false, I now have 2 options. I'm below 7, but I could not be below 4, or I'm below 7 and below 4, right? So I can put another case structure inside the false case like this. So now, if I'm not greater than 7 and not less than 4, what does that mean I want to say? I'm not too high and I'm not too low, so I want to shoot the ball. So I can grab my shoot the ball and put it in here. So false, false is shoot the ball. How do I get shoot the ball out to this instruction set? I've already got a tunnel set up here. I need to have another tunnel set up there. And then I need to also connect this tunnel to that tunnel. Do you see all that connection that needed to happen? You may want to give yourself more room. In fact, you know, let's just do this now. Control, click, and drag. Control, click, and drag inside of a structure gives you more room in the structure. That's worth the price of admission, by the way. So you can control, click, and drag inside of a structure. And now you can see it better. You got more room. So I've got shoot the ball here. What happens if I'm false on my greater than but true on my less than? That means I'm too low. Now this conditional terminal, which gets hooked up through the edge wall of the outside case structure and into the inside case structure, right? Control B. That needs a new string constant that says don't shoot, move up. So this is the most complicated exercise we've done yet. There's a lot of things you have to do. We're going to delete the beep. We're going to delete the select because we're not using the select anymore. All right, I wanted to do this with case structures so you can see it. You could do it with the select function because all we're doing is passing information, but I wanted to show you how to do it with case structures because I think it's more challenging. And this is the hardest thing you can do in the whole decision-making, algorithm-making process for the robot, is to do multiple decisions. So now we've got a decision that is true on my greater than. We've got a decision that is false on my greater than and true on my less than. And we've got a decision that is false and false. Okay? Now watch this work. Let's turn the light bulb on and run the program. So now 7.9 is greater than 7, so which case should I go to? True. Didn't even look at that false case, so it doesn't matter that there's an extra case structure in there. What if I change the number to 2.9? That should be false on my outside case structure and true on my inside case structure, so I get that solution. And if I go between the two, the light bulb should come on and I should get the shoot the ball. So now I am false, and that tells me to shoot the ball. Does that make sense? And you can do this forever. You could have a case structure inside of the false case structure. So now you'd have 1, 2, 3, 4, 5 options. You could have something inside the true. You could have any number, an infinite number of nested case structures. Does this make sense to everybody? Try to implement that. I'll put up the instructions for it. Remember to delete out the select. Actually, you don't even have to delete it out, but you're going to have to make new wires. And I like it better this way. Delete out the select, delete out the beep. If you want to put the wait statement in, you can. Whoops. And that's multiple decision making in LabVIEW. We're in the home stretch. We're almost there. You got 2 more skill building activities, and then we're going to go into the robot code. Have at it.